we've seen that if we complete the limiting process, we end up with the integral shown here. Integral from 0 to 1 of the integral from 0 to 2 minus x squared of 1 over the square root of 1 plus x plus y squared dy dx. Our original region is described by the function 2 minus x squared. Our density is our function 1 over the square root of 1 plus x plus y squared. Let's sketch a picture that kind of summarizes where we are. Okay, we've got this region of the xy plane beneath the curve y equals 2 minus x squared with density function 1 over the square root of 1 plus x plus y squared. Our region can be described as follows. It can be described as 0 less than or equal to x less than or equal to 1. And if x is a point in this region, then y runs from 0 to 2 minus x squared. So for any x between 0 and 1, we let y run from 0 to 2 minus x squared. And we have a description in terms of inequalities of this region. Now, we've seen that if we analyze the mass of this region, that it can be represented by the integral from 0 to 1 of the integral from 0 to 2 minus x squared of our density function with respect to y, that integral with respect to x. The description of our region appears in our expression for the integral. X runs from 0 to 1, so x runs from 0 to 1. For every x, y runs from 0 to 2 minus x squared. So if x is here, then y runs from here to here, runs along this strip, so that we integrate our density function from y equals 0 to 2 minus x squared, integrating that result with respect to x from 0 to 1. Our limits: x from 0 to 1, y from 0 to 2 minus x squared. Now again, I'm not going to integrate this function. It's not going to be too difficult to integrate. We're going to have 1 over the square root of 1 plus x, which can be regarded as a constant, plus y squared. With a change of variable, we're going to make that into a 1 over the square root of 1 plus u squared, and that's going to be an inverse sine. Now, we're going to have an inverse sine then of something that involves 2 minus x squared and x, and that might be difficult to integrate with respect to x, but the integral we see here does represent the mass of this region with this density function. I'm going to perform a simpler integral. I'm going to integrate from 0 to 1, and then I'm going to integrate from, let's just say, 0 to x squared. And the function I'm going to integrate is just going to be, let's say, x y squared. So I've written down this integral. The integrals are pretty simple. We integrate x y squared with respect to y. X is going to be regarded as a constant, so I could bring the x outside of this integral if I wanted to. Integral of y squared, an antiderivative is y cubed over 3. If I substitute 0 and x squared for y cubed over 3. Well, let's go ahead and do a couple of steps. That's going to be x outside the integral times y cubed over 3 evaluated between x squared and 0 dx. What's y cubed over 3 evaluated between x squared and 0? Now that's very straightforward. At 0 we're going to get 0. At x squared we're going to get x squared cubed, which is x to the 6th. So we have x times x to the 6th, which is now going to be integrated with respect to x. And we see that having integrated with respect to y and substituted limits which are either constants or functions of x, all the y dependence is out of the expression, and we're left with a function of x to integrate with respect to x. Now, x times x to the 6th is x to the 7th, so that's going to be the integral of x to the 7th from 0 to 1 dx, and that's going to be x to the 8th over 8 evaluated between 1 and 0, and that's just 1/8. So if our integral is set up properly, an inner integral with respect to y between limits that don't depend on y, and then an integral between fixed limits on x, we're going to be able, if we can do the integrals, we're going to be able to evaluate this from the inside out, and everything's going to make sense. And after you've done a couple of examples, this process will make perfect sense to you. And the only questions will then be, how do we set up the description of the interval, of the region? Okay, this region again was described in terms of these inequalities. In general, our regions will be describable in terms of inequalities, and we want to make sure that our inequality for one of our variables is expressed in terms of the other variable. That quantity will then be the quantity with respect to which we do our inner integral, and that's kind of a complicated phrase that I just uttered, but this will be our inner integral. Our inner integral would be, in this case, with respect to y, our outer integral with respect to x. We also need to decide what it is that we're integrating. In this case, it's our density. In other examples, it might be some other aspect of our region.